Hey guys, welcome to lesson number 7, Intro to Piecewise Functions. Full disclosure, I have already recorded this video, but the audio was not cooperating, so here we are again. Hopefully second time will be the charm. Let's just go ahead and jump right into it. You're going to need just about everything you already have needed for these lessons: a writing utensil, a blank sheet of paper, and a calculator. Calculator doesn't need to be fancy or graphing, just a for function will do you well. And definitely you want to take notes on this because this is our first set of new content. So let's start strong, pull out those notes. Let's get started. So as always, I'm going to review what exactly is going to be on Delta Math. So there's 3 sections. One is writing equations of lines, which is very straightforward. You see a graph of a line. You want to identify slope and y-intercept and then put that into a linear equation. So y equals mx plus. Step 2 or section 2 is evaluating piecewise functions graphically. And section 3 is evaluating piecewise functions, that is algebraically. So all 3 of these sections actually have Delta Math created videos. We'll go through some practice problems with you as I usually do. I will not be reviewing anything for section 1 because that is so heavily review. It's not even you didn't even learn that in pre-cal. So if you need one-on-one support with that, I'm here for you, but we're only going to be focusing on the piecewise portions. So without further ado, let's talk about what a piecewise function is. So make sure that you are writing this down somewhere. So a piecewise function is a function that's composed of multiple equations over different domains. So the key with piecewise functions is piece. There's pieces. So you already know what a function is. We are just now connecting that to a different type of function that has multiple pieces. So with that being said, then now there are certain steps that you always follow to evaluate a piecewise function. Step 1, identify the input. Step 2, determine which piece to substitute into. And step 3, substitute and simplify. So when you evaluate any function at all, and evaluating functions is like saying like f of 6, g of 9, h of 36, all of that, you always do steps 1 and 3 anyway. You always identify the input and you always substitute and simplify. But since this is a piecewise function, you are also doing that middle step where you have to pick or determine which piece to substitute into in order to simplify. So we're going to go over that protocol together. Before we do that, let's talk a little bit about vocabulary. So this is exactly what a piecewise function looks like, top to bottom. This is everything you need to be able to solve a problem. So you have the piecewise function, that's just the function symbol. After that, I want to draw your attention to these expressions. So this is what I mean by the different pieces that we have. So there's one expression here is a quadratic because it's being squared. And there's another expression here, another piece, I'm going to use that interchangeably, which is a linear one. And then last but not least, you are also looking at domain. So this is where your domain is. Domain is exactly what you've always been thinking about. Domain is all possible x values. So when your x values or your input is less than 3, then you are using that top piece or that top expression. If it's equal to or greater than 3, then you are using the linear or this bottom expression down here. So those are all the parts of a piecewise function. Here's another example. Take a second to examine that, maybe compare, contrast, what's similar, what's different. Notice that those basic 3 pieces, those basic 3 vocabulary words stay consistent. All right, now let's jump into our first example. So here's an example where not only do you get the algebraic function, but you also get the graphic function. So on Delta Math, if you remember, so section 2 will give you your piecewise functions graphically, and you have to evaluate that way. And then on the third and last section, you're going to evaluate it algebraically. So this is what your questions are going to look like. So it's asking you to evaluate f of -2. Down here under the slide, I have the 3 steps you need. 1, you are going to identify the input. So in the question, we want to see what is the input. So the number that's being put in is -2. You can easily do it graphically by looking at your input, and then you want to see, okay, so at -2 right here, right? -2 is my input. What is my output? My output, and that means I'm substituting into this piece right here. My output is at 4. That's it. You can also do this algebraically by looking at the domain and seeing, okay, -2 is less than 2. And so I'm going to substitute it into this top piece right here because it satisfies this domain. So -2 squared is 4. So that's a way to check your work, or just another way to solve that same problem. Go ahead and answer this question on your own. Now here's another example. So still a piecewise function, still has the same vocabulary, the same body parts of a piecewise function. The only difference is that there's 3 pieces. So I will go ahead and model these first 2 problems with you.
All right, so now let's do some examples where we solve them algebraically. So this is the same problem that we had on the slides. So I'm going to do the first 2, and then you are going to do the second 2. So I've rewritten the problem, I've rewritten the questions, and I've also rewritten the 3 steps that it takes to solve these problems. So let's start with A. So step 1 is to identify the input. So you are going to identify, right, in this problem our input is 2. So we know that this is our input. Then you are going to determine which piece to substitute into. So you want to figure out, this is my input or my x value, what domain will this fit into, right? Is 2 less than -3? No. Is 2 between -3 and 6? Yes. Meaning that if it satisfies this domain, then we are going to substitute into the matching expression. So we're going to substitute into this quadratic expression. And then once we determine that, we know that we're using x squared minus 5. We are going to substitute and simplify, substituting it into the second step. So anywhere there's an x, I'm going to put my 2 or my input. And so I get 2 squared minus 5, which is 4 minus 5, which is -1. Done. Now let's do 10. So g of 10. So we've identified our input, 10. Now we have to choose which piece to substitute that into. So we know it can't satisfy this domain because 10 isn't less than -3. Is 10 between -3 and 6? No, because 10 is too large. Is 10 greater or equal to 6? Yes, it is greater than 6. So we are going to plug it into this expression. So we've chosen this expression. Now, since there are no x values for me to plug 10 into, then this is just my answer. That means that if your domain, if any input value is greater than or equal to 6, your answer is just straight up going to be 7. And that happens, and it probably will happen on your homework as well. I hope this was helpful. Now apply this to the next 2 CFU questions you see pop up.
All right, guys, now that you have done some examples with me, go ahead and answer this question on your own. Now that you've done CFU number 2, go ahead and do CFU number 3. All right, hopefully that practice was helpful. Let's do one last piece. So can a piecewise function have undefined values? Up until now, you've only had piecewise functions that have given you a number, some kind of output, right? But think about this. Is there a situation in which you can actually have them be undefined? You're thinking, dang, if Miss Abdi is asking this question, then it's probably true. Yes, a piecewise function can have some undefined values. So if you look at this function right here, you can't even see where it ends, but it ends right about here, around where my video starts. There are 2 pieces to this piecewise function, right? But what you haven't seen very much of is a little gap between these 2 domains. So for example, if I ask you for f of -2, there is no defined part of this function available, so that answer would be undefined. Yep. So hopefully that was really helpful. As we move into new content, go ahead and start budgeting more time for pre-cal, because your lessons are going to start taking up a little bit more of your time.